when we want to sketch something, there is a connection between Cartesian equation and solving equation. So this is a Cartesian equation. Y equals to 2x plus 1. Now this is a solving equation. 2x plus 1 equals to 0. Now we know what this picture looks like. It's a line. And we know when we solve this, x equals to minus half. So when we send both sides, we subtract by 1, and then both sides we divide by 2. It is minus 1 by 2. Now the question is there any connection between the two? Well, this is the connection. When a Cartesian picture cuts the x-axis, so if this is the x-axis, that is the solution of the equation. So if you put y equal to 0, x equals to minus half, that means this is where the picture cuts the x-axis. That's what it means. So if you want to solve this, suppose you are asked for an equation, solve this equation, x squared plus x minus 6 equals to 0. And you know how to solve this. You can solve this using Quadratic's factoring rule, middle term break. We can do x squared, 6 1 the 6, so thrice x minus twice x minus 6 equals to 0. We can take x common and it becomes x plus 3 minus 2, x plus 3 equals to 0. And we can write x plus 3, x minus 2 equals to 0. So therefore, x equals to minus 3 or x equals to 2, we have two roots. Remember, a quadratic equation can have at most two roots. Now, this is the same as visually having a sketch of y equals to x squared plus x minus 6 and finding out where it cuts the x-axis and y-axis. So if you want to solve this equation visually, it is the same as finding it where it cuts the x-axis. So it cuts the x-axis at minus 3 and it cuts the x-axis at 2. So that's it. That's what it is. So this is very, very important that you remember that. A solving equation, meaning something that has one variable, can be solved using algebra, or you can take it as the Cartesian equation where we have two variables x and y and have a picture of it. The solution is where does the picture cut the x-axis. Remember, at the x-axis y equals to 0. This is the connection. At the x-axis y equals to 0. So now we can use this concept to do the reverse. So for example, you're asked to sketch an equation y equals to x minus 3. So now you can find out where does it cut the x-axis. So you can write when y equals to 0. X-axis means y equals to 0. Now it becomes a linear equation. So we find the root of the linear equation. So that means at the x-axis this picture will cut at 3, and it doesn't have to be very accurately. It could be quick and dirty. That's it. Now you want to find where does it cut the y-axis. So when y equals to 0, when x equals to 0, in this vertical number line x equals to 0. So we can write y equals to 0 minus 3, which is minus 3. That means this is minus 3 and we join it. That's it. That's the line. So we can go now back and forth using the concept of algebra where we solve equations, and using that we can sketch it. Suppose you have two Cartesian equations, y equals to 2x plus 1, and suppose you have y equals to x squared plus x minus 1. Now remember, when you have two Cartesian equations, the picture is, so this is like this. So minus 3 and 2, it cuts the x-axis at minus 3 and 2. This is, let me make this minus 6. So this is minus 6. And this is minus half and 1. So this is this. So these are the two pictures. So this is the same as solving simultaneous equation y equals to 2x plus 1, equation 1. Y equals to x squared plus x minus 6, equation 2. So how do we solve it? We can solve this by substitution. X squared plus x minus 6 equals to 2x plus 1. We can write x squared x minus 2x is minus x. We can write minus 7 and we can solve this. We can find two values of x. This is the same as finding the point of intersection of these two pictures. So remember, in Cartesian, solving uh, two simultaneous equation graphically is finding their point of intersection. So the x value over here, this is one of the root, and this is another of the roots. So if you want to know how many roots this equation will have, you can say visually they will have two roots. Why? Because these two pictures, since they're Cartesian, they're going to be pictures, intersect at 2 points. Now, it is often seen that quadratic equation sometimes does not have any root. We cannot find any solution. For example, this is a solving equation, x squared plus 1 equals to 0. Now, what does that mean? We cannot solve it. X squared equals to minus 1 and x equals to plus minus square root of minus 1. If we bring out our calculator, so this is what it looks like. If you write square root of minus 1, that's math error. So what do we do in this situation? What does that mean? Well, visually, it's very simple. It means the picture, if you remember, y equals to x squared is this specific shape, and y equals to x squared plus 1 is slide upwards by 1 unit. So remember, so this is what the picture looks visually. It means it doesn't cut the x-axis at all. Remember, the root of an equation is where does the Cartesian equation cut at the x-axis. So when we have regular equations, it means we just solve it, we find the value. But if we cannot find the value, or if you want to know the connection of solving it graphically or visually, it means where does the Cartesian picture cut the x-axis. So here, for this particular uh, quadratic equation, it doesn't have any root because the Cartesian equation doesn't cut the x-axis at all. Now, if we have an equation that looks like this, it has only one root, one unique root. So what might be an example of this? An example of this might be x squared minus 2x plus 1 equals to 0. If we solve this, it becomes complete square, x minus 1, they are the factors. And we solve x equals to 1 or x equals to 1, so they're the same. It means it cuts the x-axis at 1 point. So visually, so the equation of y equals to x squared minus 2x plus 1, this is what it looks like. If we have two values of x, it means that is the turning point. And of course, if there are two different roots, it would cut at two different points. So that's it. So by definition, a quadratic equation can have at most two roots, meaning it can cut the Cartesian quadratic equation can cut at 2 points, it can cut at 1 point, and it might not cut the x-axis at all.